So before we get going, I'm interested, who was in the last session in here that Michael Dawson gave on Node and Kubernetes? Okay, good. So this is going to build on top of that. So welcome. I'm going to be talking about FaaS meets frameworks. So how does function as a service and cloud functions actually work on top of existing frameworks, and how do you use that as a way of easily getting to Kubernetes? My name's Chris Bailey. I work in IBM on cloud-native runtimes, developer tools, and generally making it easier to build multi-microservice cloud-native applications. So I'm going to start off by talking about what is FaaS, or function as a service. So has anybody seen this kind of diagram before? The horizontal axis is kind of like ease of infrastructure and scaling. The vertical axis is ease of development and kind of delegating logic and implementation to runtimes and making it simpler to develop. You get this kind of arrow on it, and it has infrastructure as a service, container as a service, platform as a service, and then function as a service. Has anybody seen this before? Okay, so the kind of scope here is, if you're doing virtual machines with something like OpenStack, you have to bring the entire stack of software. So you're creating a virtual machine with an operating system, with an install of a runtime like Node.js. You then bring an application that has all of the packages that you want, you develop the code, you then deploy the virtual machine. If you want multiple instances, you deploy multiple virtual machines, you deal with a proxy load balancer in front of it. Essentially, you do everything, but you have complete control to do it exactly the way that you want to. As you move across the axis, you move to Kubernetes. This will now orchestrate multiple containers for you. So you don't actually have to worry about managing virtual machines or instances. That can be done by the platform. You're bringing a Docker container that is an operating system, which you've then pre-installed, pre-configured. You're bringing your own Node runtime. You bring a Node application on top of it. You move over to platform as a service. You don't have to worry about operating systems or installs of runtime. You just bring it all in an application. And when you get to FaaS, you don't worry about any of that. You just bring individual functions, right? So individual small sets of lines of code, and that's it. So IaaS, as I said, most complicated, most control. CaaS, container as a service, you start to delegate scaling to the platform and some of the configuration. Platform as a service, you now focus on applications and not how they're run. And functions means you get to concentrate on a function and not even how the rest of the application works. So Wikipedia defines function as a service as something that provides a platform that allows you to develop, run, and manage application functions without having to build and maintain infrastructure. So that's pretty much what we've just described. It also says it's one way of achieving serverless. Right? Traditionally, when people hear about cloud functions, they think serverless. And that's true because functions and function as a service is one type of serverless, but it's not the only type of serverless. So if we look at this axis, you have servers in the bottom left-hand corner. This is where you build servers yourself, you deploy servers yourself, you manage everything. At the far end of it, when you move to function as a service, you have serverless in terms of scaling. When load comes in, you actually have instances of that function based on the load. Serverless is actually effectively an on-demand scaler. Right? The more requests that come into the system, the more it scales out to handle the load. So you can actually scale from 0 to infinity as long as you don't mind paying a large enough bill. Now, on the other axis, which is that you get from FaaS, is functions programming. And this is reducing the amount that you actually have to develop and maintain yourself and delegating a lot to the stack. So the horizontal axis is all about scaling, right? Not having to deal with multiple instances and load balancers. And the vertical axis is all about ease of development. When the two come together, you get function as a service. So function as a service is both serverless and functions, but you can actually have them completely independently of each other. So FaaS is serverless plus functions. So how does FaaS actually work? How does it let you write small units of code and scale to infinity under it? So this is the model for Apache OpenWhisk, which is an open source implementation of a function as a service platform. And what happens is, as a developer, you can write a function. So this is the function signature that you've got for Apache OpenWhisk for Node.js. You have a function which you then export. So you do exports.handler equals the name of your function. And you declare something that receives one parameter, which is params, and you return. So that's the function signature. One parameter in, one parameter out, and you can make it do whatever you like. But that's the entire function signature that you get. When you write that code, you generate what they call a function handler. If you then want to test that function handler, you have to deploy it to the function as a service platform. So you deploy your function handler, you get the ability to do run, test, debug on the functions platform. And that function handler is now running and live. It runs on top of a runtime because something has to invoke your function when a request comes in. And then you can have a real user, and that real user can make a request, and your function gets invoked. And that's how OpenWhisk largely works. And at the results on the right-hand side, it will scale on demand. As new requests come in, it will make sure there's enough runtimes to handle it. And the simplified development is, I didn't need to build a Docker container. I didn't need to deal with versions of Node. I didn't need to have a package.json if I don't want to. They do let you require in packages if you want to. But I only had to write a single function declaration, put some code into it, and it works. Now, let's actually dig a level deeper and see how that actually gets put together. So the OpenWhisk runtime is actually a few layers itself. The bottom layer is a Docker container. So it is actually building a containerized runtime. On top of that, it has Node.js running an HTTP server. And inside that HTTP server, there are two REST endpoints. There is a post on /init. And what happens is when you deploy your function handler, it actually calls the runtime on /init and gives it your code. And that runtime then becomes initialized with your function handler so it can be executed. And when a request comes in, it calls a post request on /run and gives it the parameters from the request. So you're actually running a full Node.js stack, a full microservice in order to run that function. And the full microservice under it is responsible for making it run on the platform, being able to do monitoring, being able to do request tracking across functions, and so on. So what you've actually got there is a full microservice that's just been built for you. In terms of scaling, the way it works is when you have a second request, it actually spins up a second instance. So if I have 4 requests, I have 4 instances of my function that are running. So it has a model of 1 request, 1 instance. So what are people using FaaS for? Well, the biggest use case for serverless and FaaS is actually to build REST APIs. So the number one use case, 73% of people surveyed about what they're using functions for said, I'm building REST APIs. Another 26% said they were building mobile backends, which is essentially REST APIs. So the largest use case by a long way for functions is actually just to build REST APIs. But the problem with that is the function signature, right? Who here has built REST APIs using something like Express? Right? So you're used to request response next. You're used to having a bunch of APIs that you can then call against the request to deal with headers if you want to. Response lets you set headers. Unfortunately, this just gives you 1 parameter in, 1 parameter out, and it's not designed to help you build REST APIs. It's designed to be flexible instead. It's designed to be that it can be invoked by any kind of request. It doesn't have to be REST. It could be a cron job. It could be a change in a database. But if you want to build REST APIs, it's not a very helpful API. And OpenWhisk isn't alone. This is the same for all functions implementations. This is AWS Lambda. This gives you a slightly different function signature. You've got event call context in callback. But again, you've got this problem that it's not designed for a specific use case or a domain. You have a generic API, but you're probably going to be wanting to build REST APIs. So wouldn't it be nice if you could build functions using the APIs that you're used to? And given that it's actually going to build it into a full microservice anyway, we could build that microservice using well-known frameworks like Express. So that's what I'm actually going to show you how to do. So there's two technologies I'm going to cover. One of them is called Appsody, which was talked about by Michael Dawson in the previous session to a certain extent. And the other one is Knative, which is a project that builds on top of Kubernetes that provides serverless. And when we go back to that axis, what happens is Appsody will let you provide a functions programming model. So it basically allows you to delegate lots of development to a stack, to a runtime, and then let you develop on top of it. And that then builds a microservice. And then you can use Knative to deploy it in a serverless fashion, so it scales on request. Now, that then says you bring the two together, you bring the two axes of FaaS, so functions and serverless together, and you can build a FaaS platform that does exactly what you want it to, but lets you use Express APIs if you want to. So if we start off with Appsody, it consists of three things. There's a CLI that lets you do development, and there's also some IDE plugins for it. There's then a sense of stacks. Now, these stacks are actually available at multiple levels. I'm going to show you the top level, which is building a function. But what Michael Dawson showed in the last session was how you can build an application with this style, but you can build an entire Express app. You can have access to the Express app object itself. You can work with routers. You can register middlewares, and it will still deal with metrics and monitoring and how you deploy to Kubernetes for you. And there's a lower level where you can say, actually, I've got a Node application. I just want you to deploy it and deploy it serverless. And then there's a bunch of technologies around how you deploy and manage it in Kubernetes. But rather than kind of talk about how it works, I'm going to show you how it works. So if I bring up the console, and make sure my directory is empty. Yep. So I'm going to make a new directory for a backend. And then I'm going to do Appsody init, and I'm going to tell it the type of project that I want to create, which is Node.js functions. Now, this is doing two things. It's going to create a very, very simple project structure for me. So I've got something to develop from, and then it brings down that functions runtime that I'm going to use. If I then open this in VS Code to see what I've got, and let's make this a little bit bigger. So what I've got in my project is I've got a package.json, so I can add dependencies as normal. I've got a git ignore file and so on. I've got an Appsody config file that gives my project a name, and it says which version of the runtime I want to use. And then I've got a function. And this function says for get requests, so module.exports.get, it says if there's a get request on the URL of / run this function, which is hello from Appsody. So if I then just run it, and I can do that with Appsody run, and what that does is it just takes my code and applies it to the function's runtime locally. So this is all going to run locally on my laptop. I now have a project that's running on port 3000. So if I go to localhost 3000, I get hello from Appsody. So I've just built and deployed a function into a container, and I've got a local running version of this. Now, in order to do development with that function runtime, if you're used to using something like NodeMon, so you make changes, it gets reflected immediately, the same system applies. So let's say I want to start making some changes to my function. So let's create an array with some data in it, and I'm going to have an orange, and I'm going to have an apple, and I'm going to have a banana. And then instead of saying hello from Appsody, let's get it to return a random entry. So hopefully, and people can correct me if my programming is wrong, we want math.floor for math.random, and then we want to times that by fruits.length. And hopefully, that look okay to everyone? Well, we'll see. I'll go back to my browser, and it says apple, it says orange, orange, apple, banana. Okay, so it's working. So it's immediately reflected the changes that I am making in the container as I build and run it. So that's given me a function that I can run locally. Now, as well as giving me function programming, I can also, in terms of iterative development, I can set a breakpoint if I want to. If I just close that down and then say I want to rerun in debug mode, I can run as a debugger. And now that's up and running, I can connect the debugger. It's connected, and if I reload it, it jumps to the breakpoint. So even though this is all running in a function's runtime inside a container, I've got everything that I'm used to running. So I've just let that go again and disable the breakpoint. Now, as well as giving me this iterative development environment, one of the advantages of me not owning the entire application is the rest of the microservice can do stuff on my behalf. So one of the things it gives you is very simple. It's this. It's a health check endpoint. And that's because this is going to get run inside Kubernetes. And Kubernetes will do a couple of things for you. It will automatically restart any application that is struggling, right? It checks for liveness. And when it pings your liveness endpoint, if it doesn't get a response, it restarts you. But you can also register a number of callbacks, which you can do as promises, to get some checks run against your application to determine whether you want to tell Kubernetes to restart you. As well as liveness, there's also readiness. Works in exactly the same way, but rather than being restarted, it will take you out of load balancing until you report that you are ready to receive workload. So that's built into the function's runtime for you. You also have the ability to say, I want to have metrics. So there is a metrics endpoint. This isn't designed to be human readable. You'll see what it's for later. And during development time, we also add a metrics dashboard. No, that's not it. That's the URL. There we go. So what this provides, and I'll just hit the endpoint a few times, is this provides an inbuilt view of the performance of my function. So it tells me about the CPU usage of the function, it tells me about its memory usage, it tells me about incoming HTTP requests and my throughput. It also knows about the JavaScript heap, it knows about the event loop time, latency, and every other request. And the socket IO request here is this dashboard itself running. As well as that, I can turn on profiling. And as part of profiling, it will start to generate an inbuilt set of flame charts for me. So it's got full profiling of my function as part of the function's runtime. So if I now disable the profiling, and in fact, I will just stop my app. So that's now inside my function. Now, one of the differences about building functions this way is I have a full framework. And that means it's not just one function I can run. I can put as many into the application as I like. So if I drag in another function, and what this function does is, if I just expand the screen, so this is going to make a request. So it hosts a function on /proxy. And what it does is it makes a request against the host and reports fruit plus whatever the response was from the host. By default, the host is localhost 3000. It will also look up default backend URL from an environment variable, and you'll see why we're doing that in a second. So if I again go and run that, and do an Appsody run. This is doing exactly the same thing. It's just restarting the runtime, which I stopped from debug mode and I put back into run mode. And now when I run my application and I go to /, I still have my random fruits. If I go to /proxy, it's just got an annotation in front because it's calling back to itself. So I've got two functions running inside the runtime. This is all running locally on my laptop. So the next thing we're going to do is we're actually going to deploy it to Kubernetes. Now, the way I do that is super simple. I just say deploy it. Now, this is doing two things on my behalf. First of all, it's building a best practice Docker image with my application in. So it starts off by, all of your local development uses a standard Node image, but for production, we're using the Node Slim image. So you don't need things like NPM in a production image because all of your modules are already installed. So this generates a production image that's 190 meg in size rather than 900 meg, and then it's deployed it to Kubernetes running locally on my laptop. And that says it's now available here. So if I go to that URL, on /, I have my random fruits, and if I go to /proxy, I have exactly the same thing that I have locally, but this is now running inside Kubernetes. Now, a way of showing you that that is true is I can go to this, which is a Kubernetes application viewer, and it has now detected that I've got my deployed backend. I can click on it. It's deployed as two resources. So in Kubernetes terms, you have deployments and then you have services. And services expose a deployment. So I have a deployment and an exposed service. It knows that it's a project called backend, that it's made with Node.js functions version 0.1.6. If I actually create a Git project for this, it knows where the Git project is, what the commit was, and it will jump you back to the Git project. I can also go to the liveness endpoint that I showed you earlier if I want to, or I can go to the metrics dashboard. Or can I? This is always the danger of doing things live, isn't it? What happened to my metrics dashboard? There we go. Just need to make that connection available. Right, so let's reload that. There we go. So this is my metrics dashboard. So it jumps me through to the metrics dashboard inside Kubernetes that knows about my application. So the registration that I've got an application that has monitoring, that's done with Kubernetes automatically. That's part of using the functions runtime. It knows about request durations and the URLs that they're on. It knows about request count, CPU usage, memory usage, etc. So I've written just a simple piece of code, but the whole part of getting that to Kubernetes and scaling it has been done for me. Now, this is just one microservice, but I want multiple ones to talk together. So that's actually pretty easy to do as well. So for my back end, what I'm going to do is I'm just going to take its configuration, which was generated for me, and I'm going to say that under the service, I want to provide something that people can connect to. I'm going to set its category as OpenAPI. So I'm saying it exposes a REST endpoint. And by default, I would like people just to connect to /. Now, once I've done that, I can do a run task of an Appsody deploy. Where are we? Appsody deploy to redeploy it. And now I've got a function which I'm saying I want other functions to be able to use. So whilst that's happening, I'm going to start a second project. So if I create a new project called front end, let's call it front end. There we go. And get it, yep. And do Appsody init, Node.js functions. So this is doing exactly the same thing I did when I built the backend project. It's just building a front-end function. If I then open VS Code, for my new project, what I'm going to do is very simple. I'm going to go to my last project where I had this proxy function, and I'm going to drag it over. Now, what we said with this proxy function is that it decides where it connects to by using localhost 3000 or this environment variable, default backend URL. So what we're going to do is we're going to make the front end function look up that value when it's deployed to find my backend function and connect the two together. Now, I'm just going to do a build to make sure that it builds properly, which it should do. And this is going to result in a local Docker container, but by building it, it runs the tests as well. And then once I've done that, I'm just going to set it up to connect to the backend. And once I've done that, I can deploy it. I should be able to connect to the front end, and the front end will know about the back end. But actually, just to make it clear, let's change the text that it prints as well while we're at it. So I'm going to take my deploy configuration, and I'm going to go to the service, and I'm going to say that this wants to consume something. So it consumes something of category open API that has a name of backend, and it's in the default namespace. And then, if everything comes together, I can do an Appsody deploy, and I'm now going to have two functions deployed, and one will connect to the other. Again, this is building a production Docker image. That Docker image you can actually run any way that you like. You don't need to be using this deploy system to run it because it is just a full microservice. Oh dear. Let's try that again. And check I didn't typo. So I did typo. So where are we? Yeah. Yeah, you're probably right. Yes, I mean, Kubernetes deals with all of that for you because it sees each of these as its own containerized runtime. This is one of those things where, given the time, I'm going to have to, anyone that wants to see it working, I will show them afterwards, but I will quickly drop back to the slides just to show you that, so that's kind of the function programming piece. What actually happens here is, in the CLI, it does a lookup of the types of applications that I want to build. We built a function. There's local dev debug cycle. It pulls down the stack as you build, and then it takes that function, and once you've built it, builds a productized version of the stack, and then deploys it to Kubernetes, and then it integrates with everything in the platform. So we've got the monitoring, we've got the dashboarding, and so on. Now, what Knative does for you, just to finish that piece off, is when you deploy Knative, its style of serverless and scaling is very different to OpenWhisk. When you have one request of Knative for serverless, you have one instance of your microservice. But one of the other advantages of using a full framework is, so who here runs 50 parallel requests, concurrent requests through Express, right? I would hope most people don't worry about the concurrency of Express, right? It's more than capable of handling multiple requests at the same time. So by default, Knative will say, well, if I have a second user, right, I don't need 2 instances of Express to handle 2 concurrent users. It still only has 1. In fact, if there's 4 of them, it will still only use 1. If there's 100, it will still use 1. If there's 101, it'll add a second one. That is configurable. You can make it any number you like. You can make it 1 if you wanted to. But because frameworks already provide concurrency, it lets you put more requests through a system. So it's a system where it does serverless based on full microservices, and Appsody helps you build those microservices. And that's where I'll leave it. So those are the 2 projects. I'll be at the IBM booth today, tomorrow, if you've got any questions. And everything's open source projects. Thank you.